Steel wheels clinging to muddy slopes. Tractors with retractable, hoof-like feet. And machines that float instead of roll. Early tractor designers built some of the strangest farm vehicles in all history, each one real and documented, but nearly all forgotten. Decades before modern safety standards or practical blueprints, these bizarre inventions risked lives and fortunes in pursuit of progress. What drove their makers to gamble everything on such radical designs? And why did so many vanish from the fields without trace? The answer begins with a century-old engineering dilemma that forced inventors far beyond the edge of convention. In 1927, the hillsides of Oregon and Washington posed a problem that most tractors simply could not solve. Traditional machines with rigid frames and fixed axles struggled on steep side slopes. The risk of rolling over was constant, and working across a grade forced the operator to lean with the machine. This was a local, practical challenge that demanded a different approach, and it inspired one of the more unusual experiments in tractor design. That tractor was the Adams Sidehill, built by the Adams Sidehill Tractor Company in the Dalles, Oregon. The model introduced a leveling system that let each rear wheel rise or fall independently. With a pair of hand levers, the operator could change the height of each wheel as the tractor crossed a slope, keeping both the driver and the chassis level while the wheels followed the land's angle. The mechanism used a set of mechanical linkages and pivots, simple in concept but unusual compared to other machines on the market. The design made it possible to work across steep, rolling fields without tipping the cab. It was an engineering solution directly aimed at the specific dangers of sidehill farming in the Pacific Northwest, where fields and pastures often run across sloping terrain. Adams was not the only maker to explore this idea, but their adjustable stance was one of the boldest attempts. In practice, the system required constant attention from the operator, who had to move the levers by hand as the slope changed. Contemporary reports describe the adjustments as slow and physically demanding, which limited the tractor's appeal. Production was small and mostly regional, as larger manufacturers developed wider, more stable machines, and as self-leveling combines and wider implements became common, the need for a highly specialized sidehill system faded. The Adams Sidehill was overtaken by simpler, more universal designs and by machines that required less active input from the driver. Today, the Adams Sidehill survives mostly in photographs and in the pages of tractor history. A few restored examples appear in private collections or museums from time to time, but for most people, it is a forgotten footnote, a reminder of how local inventors tried to engineer their way out of a uniquely regional problem, only to be overtaken by broader changes in agricultural technology. In 1912, the Lambert Gas Engine Company of Anderson, Indiana, introduced a tractor that seemed to borrow its inspiration straight from the barnyard. The result was one of the most strange early tractor designs. The Lambert steel hoof tractor rolled onto fields with drive wheels, unlike anything else. Each rim carried hinged steel pads that struck the ground and then folded away, mimicking how a horse hoof digs in and lifts off. As the pads rotated under the tractor's weight, They pressed deep into muddy soil, then retracted as the wheel turned, scraping off clinging mud and promising self-cleaning traction in the stickiest conditions. The idea was simple. Ordinary steel wheels often slipped or packed solid with mud, turning into useless spinning drums. Lambert's answer was to let each pad bite, these shed soil, aiming for the sure-footed grip of a draft horse. In practice, the gamble did not pay off. The constant pounding and grinding of dirt, stones, and grit quickly wore out the hinges and pins. Pads jammed or broke loose, and the intricate mechanism demanded far more maintenance than most farmers could stomach. Production lasted only from 1912 to 1916. As stronger fixed lug wheels and later crawler tracks appeared, the complicated hoof pad system was quietly abandoned. Only a handful of photographs and a few battered wheels in private collections remain to show how far some early builders were willing to go in pursuit of traction. The steel hoof stands as a mechanical curiosity, proof that not every clever idea survives a season in the mud. In 1914, California's CL Best Gas Traction Company introduced a tractor that stood out even among its experimental peers. The Best 30 Humpback was one of the most strange farm machines of its day. Unlike the squat, flat track layers that later dominated fields, the Humpback carried its rear drive sprockets high above the tracks, arching its back and creating a distinctive silhouette. This was not a stylistic choice, but a calculated move to keep the drive sprockets clear of rocks, mud, and debris. By lifting the sprocket well above the ground contact, Best aimed to reduce wear and jamming, and to achieve longer track life and smoother operation in the thick soils and orchard rows of California. The Best 30 Humpback paired the raised sprocket layout with a single front tiller wheel for steering. That steering system belonged more to early steam traction engines than to modern crawlers. The operator, perched behind the engine, guided the machine like a rudder, using the front wheel to carve turns, while the rear tracks supplied forward power. The track system itself was a self-laying design, with weight carried by rollers and idlers, while the elevated sprocket drove the chain above the working surface. The resulting geometry gave the tractor a high, almost hunched appearance, and it kept crucial parts away from dirt and impact. Best produced the Humpback for only a single year. Farmers, already wary of complex new machines, found little advantage in the raised sprocket design compared to more conventional crawlers. The tractor's niche, small orchards and vineyards, was too narrow to sustain broad sales, and the market quickly moved on to simpler, more robust layouts. As a result, production stopped, and the Humpback remained a rare experiment. Decades later, Caterpillar returned to the elevated sprocket concept with its D6 through D11 models, echoing the same Humpback profile for reasons of durability and serviceability. Today, the original Best 30 Humpback survives mainly in museums and in a handful of restored examples. Its unusual profile is a reminder that even the strangest experiments can leave a lasting mark on tractor engineering. Ray Muscat's Armstead screw drum snow motor did not just look unusual. It reimagined how a tractor could move across the most unforgiving winter terrain. In 1926, Muscat's invention replaced the Fordson's rear wheels with a pair of massive steel drums, each wrapped in a continuous helical flange. As the drums rotated, The spirals bit into deep snow and pushed the machine forward like a giant auger. The Fordson's standard gasoline engine, left unmodified, powered this setup through extra reduction gears, trading speed for the torque needed to plow through drifts that would swallow any ordinary tractor. The result was radical low ground pressure that let the Armstead float atop several feet of powder, carrying timber or whole sleds of passengers, where horses and tracks would bog down. Archival film from 1926 and 1927 captures the spectacle. The screw-propelled Fordson glides over waist-deep snow, towing logs and people with apparent ease. Steering was a real challenge. The front wheels, meant for guidance, often skittered uselessly in the snow, leaving primary control to the balance of thrust between the twin screws. On pure, deep powder, the system worked, sometimes brilliantly. But the moment the Armstead left its element, the limits appeared. On crusted snow, on ice, or on patches of bare ground, the screws lost their bite. The tractor could slide sideways, and the drums were battered by hidden rocks and stumps. Repairs were complex, and the conversion was costly. Forestry agencies and military observers watched demonstrations, but few orders followed. Tracked tractors soon offered better all-season versatility. Only a handful of Armstead snow motors were ever built, and today they survive mainly in old newsreels and the occasional museum replica. It was a bold, short-lived attempt to conquer winter using the simple logic of the screw. In 1948, Allis-Chalmers took an unconventional approach with the Model G, a tractor built for small-scale growers who needed precision above all else. Unlike the typical front-engine layout, the Model G placed its modest four-cylinder Continental engine behind the operator. This freed up the entire front and center of the frame, allowing for implements to be mounted directly beneath the driver's line of sight. For vegetable farmers and market gardeners, this meant cultivating, planting, and weeding could be done with unmatched accuracy. The open frame and rear engine design made the Model G stand out in a field of boxy, heavier machines. Instead of wrestling with poor visibility or constantly craning to check their work, operators could look straight down at the tools as they passed through the soil. This layout, paired with a lightweight and narrow track options, made the tractor ideal for delicate row crops and tight garden plots. Between 1948 and 1955, around 29,000 Model Gs rolled off the line, respectable numbers for such a specialized machine. While the tractor's low power and limited versatility kept it from replacing more conventional models, it became a favorite among small farm operators who valued its precision. Today, the Model G is prized by collectors and organic growers alike. Its unusual design, a reminder that sometimes the oddest solutions are the ones that last where they are needed most. In the years following World War I, French engineer Adolphe Kegresse set out to solve a problem that plagued both explorers and farmers. He wanted to move heavy vehicles over sand, snow, or mud, where conventional wheels would simply sink. Kegresse developed a flexible track system made from layers of reinforced rubber and canvas, wrapped around a set of drive wheels and idlers. These tracks flexed and gripped the ground, spreading a vehicle's weight across a much larger surface than a single wheel could provide. Citroën adopted this technology for their half-tracks in the 1920s, creating machines that could cross deserts, marshes, and rough terrain once considered impassable. The Citroën Kegresse half-tracks became well known during expeditions across the Sahara and Central Asia, with convoys of vehicles, part car and part tractor, rolling through endless dunes and snowfields. Steering remained conventional at the front, with wheels guiding direction, while rear tracks provided traction and flotation. Kegresse's system promised a new kind of hybrid mobility, blending automotive comfort with off-road capability. When these half-tracks were adapted for farm work, however, the flexible track wore quickly under the constant strain of plowing and dragging implements. Maintenance proved difficult, and the system's complexity often outweighed its advantages for everyday agriculture. As steel-tracked tractors improved, the Kegresse half-tracks faded from common use, but left a clear mark on vehicle design. Today, surviving examples are rare, preserved mostly in museums or private collections, reminders of an era when the line between car and tractor blurred in pursuit of all-terrain mobility. In the early 1960s, British engineers at County Commercial Cars set out to prove that a farm tractor could do something no one expected. They wanted a tractor to cross the English Channel under its own power. Their creation was the County Seahorse. The Seahorse began as a standard Fordson Major. It was transformed with massive, low-pressure flotation tires and a fully sealed hull. Every mechanical joint and drive shaft was waterproofed, and the engine's air intake and exhaust were routed high above the hood to keep water out. The flotation tires, wider than a man is tall, let the tractor float and paddle forward, while the rear axle powered all four wheels, even in open water. In July 1963, the Seahorse set off from the English coast, churning through waves and currents that would have swamped any ordinary tractor. After several tense hours, it reached the French shore, engines still running, and became the first farm tractor to complete the crossing. The stunt drew headlines and crowds, but the engineering behind it was more than a publicity grab. County's team had to solve problems of buoyancy, propulsion, and corrosion that ordinary field work never demanded. They waterproofed driveline components and routed breathing and exhaust systems well above the splash zone. Despite its success on water, the Seahorse was never practical for everyday farming. Salt water exposure quickly wore down bearings and seals, and the cost of sealing and maintaining such a machine far outweighed its novelty. Only a handful were built, and most were retired after brief use or display. Today, the Seahorse is remembered as a daring experiment that pushed the limits of what a tractor could be, blending showmanship with genuine mechanical ingenuity. In 1914, Yuba manufacturing engineers in California tried to outsmart soft ground with a radical idea. They built a tractor that rolled on giant steel spheres, not wheels or tracks. Each ball sat in a precision-machined race beneath the chassis, designed to rotate freely in any direction. The goal was simple: spread the tractor's weight, glide over mud and sand, and avoid the ruts that stopped ordinary machines. The theory promised unstoppable traction, especially for the Delta's marshy fields, where traditional tractors sank and tracks clogged with debris. Yuba's engineers believed these free-turning spheres would let their machine move forward, turn, or even pivot in place with almost no resistance. But the field had other plans. Every turn of those steel balls dragged sand, grit, and tiny stones into the ball races. What worked flawlessly in the factory quickly jammed in real soil. Abrasive material filled the channels, turning smooth rotation into grinding friction. Wear set in fast. Surfaces polished to a mirror finish were soon scarred and pitted. Maintenance became relentless, with farmers constantly cleaning and greasing the ball races just to keep the tractor moving. The very feature meant to conquer the land became its weakness. Only a few prototypes were built. None survived regular farm work. The Yuba ball tread faded away, its promise undone by the unstoppable force of grit. During the worst years of the Great Depression, cash-strapped farmers faced a stark choice. Keep working the land with horses, or find a way to mechanize on a shoestring. Tractor conversion kits stepped into this gap, offering an answer that was as crude as it was clever. These kits took the bones of an old car, often a Ford Model T or a Chevrolet, and transformed them into a stripped-down tractor, removing fenders, bodywork, and any hint of luxury. What remained was a simple chassis, a gasoline engine, and steel wheels bolted in place of tires. The goal was radical thrift. Use what you had, spend as little as possible, and get the field work done. The engineering behind these conversions was all about compromise. Car engines, built for short bursts on the road, now faced hours of heavy pulling at low speeds. Overheating became a frequent problem, especially in summer fields where airflow was minimal and dust clogged radiators. Many conversions lacked a proper governor, so engine speed surged and sagged with every change in load. Farmers improvised, rigging makeshift linkages or buying aftermarket add-ons, but the results were mixed. These machines could plow in a pinch, but reliability was always in question. Most were underpowered for serious draft work, and breakdowns were common. Still, for those with more ingenuity than money, the conversion kit was a lifeline, proof that necessity could drive invention, even if the outcome was temporary and rough around the edges. Today, only a handful of these home-built tractors survive. Their stories are preserved by collectors who value the grit and resourcefulness of the era. On the open plains of Minnesota, Joseph Gray tackled a problem that had plagued farmers for generations: heavy machinery sinking into soft earth. In the late 1910s and early 1920s, he built the Gray drum drive tractor, a striking machine with a single enormous steel drum in place of rear wheels. This drum, nearly as wide as the tractor itself, spread the vehicle's weight across a vast contact area and promised to keep it afloat where others bogged down. The logic was elegant. More surface area meant less ground pressure, and less ground pressure meant the freedom to work the wettest fields. But the real test came beneath the surface. All the tractor's weight and pulling force pressed down on the drum's central bearings. Steering depended on the front wheels, yet the massive drum was the heart and the flaw. The bearings faced relentless stress, heating up and wearing out faster than technology at the time could handle. When they failed, the tractor stopped cold and was stranded in the field. Only a handful of prototypes were ever built. As rubber tires and better tracks emerged, the Gray drum faded into obscurity, surviving now in museum photos, a rare, bold vision that revealed just how far ambition could push against the limits of engineering. Today's tractors look nothing like these forgotten experiments, but their DNA remains in every field. As farming faces new challenges, automation, climate change, and resource scarcity, radical ideas, once dismissed as oddities, now inspire innovation again. The line between failure and breakthrough is thin, and sometimes the strangest machines leave the deepest mark. Which forgotten design would you bring back, and why?